Alright, these ones we're going to solve for x, and the x's in different spots on these equations, but you're going to start by rewriting it as an exponential. So whatever the base of your log is becomes the base of your exponential. Whatever it's equal to becomes your exponent. And then whatever's here is what it ends up being equal to. So 4 to the 5th, 4 to the 5th. Oops, that's not right. Delete that. 4 to the 5th. There we go. 1024. So x on this one is 1024. For number 11, the thing you need to fill in here is e. ln, the base of it is e, even though you don't see it. So you'd have e squared equals x. Now, if you want to leave your answer like that, you could. That would be your exact answer. If you wanted to approximate what x was equal to, you'd have to use your calculator and do e raised to the second. So x would be about 7 so approximately equal to 7.389. So either way, works for us. Take a look at number 12. So here, your base is going to be x. So x raised to the 1/3 equals 8. Now, in order to solve this, you might find it helpful to rewrite the x to the 1/3 with its radical equivalent. So x to the 1/3 is saying the same thing as the cube root of x to the 1st. And I think for some people, when they write it like that, they understand a little bit more to get x by itself on the left. In order to undo taking the cube root of something, you'd have to cube it. And you have to do the same thing on the other side. So this cubed cancels out the cube root, so you're left with just x to the 1st or just x on the left, and then whatever 8 to the 3rd is. So 8 to the 3rd, 512. So x would equal 512. And for those of you that have the ability in your calculator to change the base of a logarithm, I would highly recommend checking this. So log base 512 of 8 is supposed to equal 1/3. So if I go to your calculator, put in the log base 512 of 8, and that is equivalent to 1/3, but if you want to just double check, you can change it to a fraction. So lots of different ways you could check your work in this unit. We take a look at number 13. 2 raised to the -4th power would equal x. You could do this in your calculator if you wanted to, or if you remember our rules with negative exponents, 2 to the -4th is the same thing as 2 to the +4th, and 2 to the 4th is 16. So if you didn't want to do that, you could just type 2 raised to the -4th, and then just make sure you convert that into a fraction. You can check this as well. Log base 2 of 1/16. So give yourself the log base 2. You could do fancy fraction here if you want. It should spit out -4. Alright, the last two in this section. For number 14, the base, even though you don't see it, is 10. So 10 to the 0 power equals x. And any non-zero power, or any non-zero number raised to the 0 power is just 1. So answer for number 14 is just 1. And then 15, base, exponent is equal to x. You can do this one by hand if you like, or if you want to use your calculator, give yourself fancy fraction, 1/3 raised to the -3rd should spit out 27. So x on number 15 is simply 27.